Testing. There we go. Good afternoon. How's everybody this fine afternoon? Doing well, I hope. Yeah? I hear you guys have a test on the weekend coming up, so, you know, that might be dampening your spirits a little bit, but fear not! For if you have studied, you have nothing to fear, right? Just like totalitarian regimes, if you have nothing to hide, you have nothing to worry about, right? So, yeah. Anyway, we were talking about file formats more generally. Specifically, we finished off last week's lecture on the subject of CSV files. CSV stands for comma separated value. Yes, very good. Rectangular data, as I was referring to it. Basically, plain text spreadsheet, right? So, writing a CSV file is very easy. All you need is a plain text editor, right? You enter the data in columns. You separate those columns with commas, or as we're going to see, other characters are also allowed, but commas are preferred. It is called comma separated value. And that's really it. Very important, though, that you do use a plain text editor when performing these manipulations. If you use something that doesn't edit the actual binary data of the file, such as a Word or a WordPerfect or a Paint program or whatever, you're not going to end up with something that is easily readable to the target program. The target program is going to expect plain text. So if you're not using plain text editor, it's just not going to work. Although, if you're not using a plain text editor, it should be reasonably easy to just copy and paste it into a plain text editor. So yeah. So, if in Python we wish to read in a CSV file, CSV files are kind of, they're sufficiently simple that it's not absolutely necessary to use the library in the case of CSV files. I always recommend using the library because you should save yourself work whenever you can. But given that the overall structure of CSV files are so simple, you can easily rewrite the functions that we're about to use without too much trouble. All you would do is read it in line by line, split it on commas, save it to a data structure, and that's basically what this is doing, right? So, step one, we import CSV, the CSV library. We open our CSV file using the regular procedure. However, rather than reading directly from the file handle, we create a CSV reader object. Grades is equal to csv.reader file handle. So when we give the file handle to the CSV reader object, what it's doing is it's collecting all the data from the file associated with this file handle, storing it all in the CSV reader object. The CSV reader object has iterable defined. Remember, we were talking about we were talking about methods, magic methods. Iterable was one of them. So if you want, you can for loop over the rows of a CSV file using the CSV reader object as the base data structure over which you are for looping. Does that make sense? Bing, bang, boom, that easy, right? So, would we care for a demonstration?
Yes, please.
Yeah. That's enthusiastic. I love your enthusiasm.
Well, I'm taking a data course where we program in R, so we do a lot of CSV files.
So what you're saying is, this is actually applicable to your life?
Yes.
Awesome.
Yeah.
I love it. I love it when my class is actually applicable to someone's life for a change. Aside from, insofar as your life is taking this course, why do I have 3 versions of this open? Doesn't even make any sense. All right. Let's just create a new whole shebang. Get it CSV example.py. That will be our source code file. And I will, all right, get it data.csv. We'll just create a CSV data file right there. Okay. This will just be, let's just make something up. Let's say grapes, oranges will to live. There we go. So, just make up some random numbers. There we go. Random data. Guaranteed to be random. You'll notice I left a couple of blank spots in it. Okay? We'll see how that works. I'm going to leave those in for now. Those might become interesting later on. By which I mean to say, I hope they become interesting later on. So, import CSV with open data.csv in read mode as file handle. Reader is equal to CSV reader taking the file handle. For row in reader, print row. Let's see what this does. There we go. So, as you can see, oh wow, that's cool. I can actually use it as a pointer. That's cool. Ah, that's cool. Anyway, like a laser pointer. Not that would be a close range. Anyway, so you can see the manner in which the data gets read in by Python is as a series of lists, right? So that's the data type that you'll be working with once you've imported it. But the question is, all right, so this is fine. This is a CSV file that has a header row, right? Hypothetically speaking, each one of these has a name or tag associated with it, indicated by the header row. How might we go about using that information which we have been given? Well, it turns out that you can have a different type of reader in addition to the regular reader. If rather than lowercase r reader, you use capital dict reader, you read it in as a series of dictionaries rather than as a series of lists. So let's try it out and see what the difference is. Boing. So, you can see we get a list of dictionaries instead. Each of the keys in the dictionary is the corresponding header. Entry in the header, I should say. Make sense? Any questions so far? Yeah.
How would we access a single row in that dictionary there? Like, what's its reference per row?
Well, excellent question. So for the time, like just using what we've got on the in the program right now, if you stored a temp, if you like created a list, right, which and you added each row to the list rather than printing it, then you could access them by row, using that data structure as indexes, right? So, for example, if my output was empty for row in reader, output plus equals row. Now let's change it back to let's put it inside of the list here. And then we could say, for example, print output at 5. Right? So that's how you can see how quickly and easily I was able to throw that together.
Yeah.
However, there should be a way of doing that, just in general. Let's see what the reader object itself is. Maybe this will work. Dict reader. And I'm sure there's a method for it. Let's see, is it in the slides? If you look in the documentation, you'll probably find a method that will read everything into one data structure rather than having to do it yourself, which would save you a couple of lines, but whatever. It's almost trivial to construct the data structure that you need once you have this, right? Any other questions? Yeah. So, one brief thing to note, if your CSV file does contain a header row, and that header row is not being used, you need to put the logic in yourself to skip it. Does that make sense? Otherwise, your program will think that it's data, process it like data, and probably you'll end up with a type error at some point. Because you're, treating strings as if they were integers or something. So here's one other very important thing to note before we move on, right? Two very important things to note before we move on. I promise this isn't the Spanish Inquisition sketch. I would like everybody to note the manner in which these numbers are represented. Are these integers? No, they are enclosed by single quotes. In Python, that means string. These numbers are strings by default. That's because the CSV reader object does not care how the actual data is to be interpreted. Its only function is to get your data from the file into Python. So, if you wanted to, one thing that you could do, throw some logic in here. For a row and reader, let's just say temp is equal to empty dictionary. Temp is equal to row. Temp at grapes is equal to integer convert. Temp at should be the string grapes. Right? You see where I'm going here? Oranges. Oranges. And will to live integer convert. Will to live. Actually, you know what? Let's make that one float, just for the sake of argument. There. So.
Space.
Oh. Space. Where?
What's with those double quotes? Because you
Oh, there is a space before it, isn't there? Yeah. Okay, that I would say that gets modified in the CSV file, to be honest with you. Well, here we go. And let's just remove the quotes here because they seem to be just going to mess us up. Note the quote and the space and the other quotes. Nobody needs that. You only need the quotations if the thing is supposed to contain a comma. So, for example, something like will to live, will to live, something like that. And now, of course, I've changed my mind again, so. At any rate, I'm just going to get rid of it because it's kind of a side point. So now, actually that might have been working and I just kind of deleted it. Yeah, that was working. I got an error. I didn't even read the error before I assumed what the error was, which is not good programming. So, could not convert string to float empty string. So I left some empty strings in there, right? What this basically would correspond to in a spreadsheet environment, something like an empty cell, right? In our environment, we're trying to convert an empty cell, right? Which, you know, not necessarily what we want to do. So, what we can do this, if this, not, if that, not, else none. Right? So, just a quick little inline if statement. This, if this entry is not an empty string, otherwise we give it just the none value. So let's see if that cures one and hopefully presents the other error. Yep. Now we're hitting the same error, but with the integer conversion. So we can take this little bad boy, copy, pasta, pasta. There we go. Everything works. Everything works hunky-dory. So yeah, is there anything else anybody would like to see before we move on to how to write one of these things to a file? Cool, all right. So, the basic workflow, you read a file in, you parse that information. This is roughly speaking, this is what I would consider parsing. To parse means to read into a computer program in a format intelligible to that program. Like a parsing algorithm is a conversion between the raw data in the file and, for example, Python's lists and dictionaries and everything being in the right data type. That's parsing. We rely on the CSV library to do like half of the parsing of the file, which is the extraction of the data as string data, but we have to push it the rest of the way because the dictionary, the dict reader method has no idea what the context of this data is or what it should be. It won't even try because it'll probably get it wrong. So that's how it goes. So in general, you read it in, you parse it out, you apply some kind of transformation to the data, and then you get data back out of that transformation. You then take that data, write it back into another file. That's how many of these things work. You're either collecting the data for the purpose of some other operation of the program, such as save files in a video game. You know, the whole point of a save file is to restore the state of the RAM of the game, right, to a certain point. Or you're just doing one of these very simple and basic I/O operations. Like, I take input, I do processing, I give output. Right? It doesn't matter what application you're talking about, right? If you're talking about big data, right, all you're doing is this process to a lot of data, right? This is like the fundamental building block of all data processing, at least with respect to modern computing, and assuming you're not getting in at like the transistor or architectural level. So if you're using a computer, this is how it works. So rather than printing output, let us for loop over output. Let's create actual output for line in output, actual output. Well, actually, we should be able to manipulate it in place. Now that I think about it. For line in output, line at grapes plus equals line at oranges times 3. Some kind of manipulation, right? With open, there we go, be nice about me type, data.csv.out. It doesn't have to be .out. You can do like output.csv, you know, scandalous pictures .png. It doesn't matter, right? From the perspective of the computer, the file format is only used for determining what types of programs are going to be used to open the file, right? You can name anything you want, as long as you're opening it with the correct with the correct program. It doesn't matter what the extension is, unless it's one of those programs that actually checks. But that's on the program side, not on the operating system side. So let's just say output.output for fun as file handle. So oh, wait, yeah. If I'm writing a file, I have to open it in write mode, don't I? There we go. So, in the same way that we created a CSV reader object, csv.reader, we now create a csv.writer object, which we will use as basically our access point to the file in the file system. So rather than writing directly to the file handle, we are writing to the file handle through the CSV reader, or the CSV writer object that we've just generated, right? Again, it's not difficult to format a list of dictionaries back into a form that would be highly intelligible as a CSV file. Again, we could whip this up quite quickly, right? All you have to do is, for the first line, write entry zeros keys, comma separated, right? So like you take the strings, you join them with comma, and then you write that line as a line into the file. Then on all the rest of the lines, you go through each line of your collected data, extract just the values, convert them to strings, separate them with commas, write them in. It's a very simple procedure, right? But if we don't have to do it, we don't have to do it, right? So, let's say writer is equal to CSV dot writer file handle. The writer object will keep track of all of the interesting and important information in the file handle. That's how it accesses it. So, for line in output, writer dot write line, just write row. Line. And that's it. That should be it. Let's try her out, shall we? So, just to see the differences here, cat data.csv. So this is what our original data looks like, right? Now we run our program. We get an error. Whoops. Oh yeah, some of it is none, right? So, okay. At this point, I'm just going to put some stuff in there since I'm basically done with that part of the demonstration. There we go. Note, it has executed and terminated with no indication. If you want, you can put some print statements in there to indicate, I am now finished. Not necessary. So you'll see that output is a file that has been created. Let me just swap these here so you can see that a little better. Because, over here we're basically just losing the line numbers, whereas over there we're actually losing. I'll try to remember to keep the terminal on that side from now on. So, at least in this lecture hall, I digress. Cat output.output. Aha, now that's an error. Interesting. So let's see what's going on with that, shall we? Oh, yeah, of course. So, I would mean to use the dict writer, not regular writer, wouldn't I? That's the problem. I hope, anyway. Let's hope that exists. Init. Yeah. Field names. Okay. Output dot keys. This has no object. What? Output 0 keys. There we go. And now it's correct. However, it has not given us our header row. So, I guess if you want the header row, you'll have to put it in manually. But you can see that the data has been modified in accordance with the modifications that we've requested. Any questions? Yeah.
How come we put output at 0?
Because output itself is a list of dictionaries. In order to acquire the list of attributes for it, I need to pick one of the dictionaries inside that list. So 0 is just like, you know, if the data structure is non-empty, it will contain 0. So that's a good one to pick for that purpose, right? Yeah. Any questions? Anything anybody would like to see done on this? Any, like, burning curiosities? No? Okay. All right. Sounds good. So much for CSV files. So, a couple of final notes about CSV files, and then we'll be on to something completely different. Accented characters in other alphabets or emoji can be tricky, especially when trying to exchange data between Excel and other programs. Some files are UTF-8 encoded. Some files are UTF-16 encoded. All of these characters mentioned tend to be UTF-16 encoded. So, basically, depending on the programs that you're transferring these CSV files between, they may be expecting either UTF-8 or UTF-16, depending on the application. So, since UTF-8 is a subset of UTF-16, it's the safe choice, right? Otherwise, you might run into errors and issues. Make sense? Good. Sometimes, in CSV files, people use delimiters other than commas. Incidentally, the use of the word delimiter here, I would argue with. There's a difference between a separator and a delimiter. Braces delimit because they indicate the limits of separators, separate the elements inside of something that has been delimited, right? So the commas are the separators, like square braces are the delimiters of a list. So I would quibble with that terminology, but you know. Anyway, some people use tabs. Some people use the vertical bar character, which you're going to see more and more of if you go on with these computer science courses. Some people even use spaces. Spaces can be tricky though. Like, whether you use space or tab, it's kind of like, you know, general white space might be the limiting factor. Like, you know, if you kind of think of like a column of numbers, and this is not so much relevant today, but you know, going back historically, this is the sort of thing that they would do, right? Let's say you had like, you know, the columns of a file, right? And you had like if you imagine all of the characters in a file as a grid, right? You might have, you know, this being the base column of one column, so you have like 0, 0, like 100, 50, 60, 9, 40, 2, etc. And then you have like either a space or a tab, right? And then you have, you know, another thing like this over here where it's like, you know, 0, 10, 20, 30, 7, stuff like that. So, you know, this here would be the delimiter, and that's like a variable amount of space characters. So, you know, sometimes people would consider the, you know, tab space space to be the delimiter, sometimes it's just tab space, sometimes it's just tab, sometimes it's not even tab at all. You break the tab into smaller characters, you know, all that kind of stuff, right? Yeah. And this is why most or all plain text editors will use what's called monospaced font. You guys know what monospaced font is? All right, that's a very easy concept. It's just font where every character occupies the same amount of space as every other character, right? So when you type in a monospaced font, all of your characters line up into nice little columns, like in terminal, this is the case, right? Comma occupies the same amount of space as 2, whereas in most like word processors, comma is just like kind of small by the end of the number, right? Make sense? Cool. If you are a true computer scientist, you prefer monospaced fonts to every other type of font. That might be a controversial opinion. I'm just putting it out there. So anyway, so each of these people who do each of these are wrong because it's called comma separated value, but you know, whatever. If you want some data sources from which you can derive CSV data, if you'd like to play around with it, basically any Excel file, you can get it to export to CSV. Most spreadsheet applications, you can get it to export to CSV. You can also operate on some Yahoo finance data if this link still works, which is improbable, but you can find this stuff all over the place. If you know what to look for, that's the thing. So, let's talk about JSON. Without looking it up, does anybody know what JSON stands for? Yeah.
JavaScript object notation.
JavaScript object notation. Very good. Excellent. So, from the name, we can infer JSON files. The original purpose of them was to transfer data between objects in an object-oriented language environment, right? This makes it fundamentally different from the CSV file. CSV files are for operating on data that's kind of independent of some kind of language or environment or programming structure, right? The data is just rectangular data. With JSON, the data that you're operating on is going to be more oriented towards the interpretation by programming languages specifically. So, JavaScript object notation, JavaScript object notation, or JSON, originally a subset of the JavaScript programming language for representing objects. Java is to JavaScript as car is to carpet. In case you guys were wondering if JavaScript is like Java. It's not. JavaScript it's an interesting language historically because it kind of, it rode the wave of the internet in a way that a lot of languages didn't. Because basically, so Java, right? The selling point of Java was the Java virtual machine. So you can take any Java program and run it on any system that could run the Java virtual machine. This was back when compatibility between systems was not as good as it is now. JavaScript is a version of Java that was written for a Java virtual machine that was specifically made for internet applications, right? So, this became very popular because the ability to send not just documents over the internet, but code over the internet turned out to be, possibly much, much, much bigger in scope than actual documents, arguably, I'd say. But anyway, so JSON files rode the wave of the internet, as did JSON itself, and eventually became a language-independent plain text format for representing dictionaries, lists, and structures composed of hierarchically arranged dictionaries and lists, right? So if you're looking at what a JSON is, it is either a dictionary or a list at the top level that contains a whole bunch of other dictionaries and lists, right? It's hierarchically arranged. If you think of it, like, think about a list, and every element of that list can be a list or a dictionary, right? And then if you do that with dictionaries as well, then you've got a concept of what a JSON is. So, they are commonly used for transmitting objects between applications. These days, there are even, anybody here heard of MongoDB? Yeah, its carrier format is JSON. Whereas with SQL, you're looking at more like a CSV type data storage in it. One of the things that characterizes a lot of these sort of new and fancy upcoming databasing technologies is that they've gotten away from like the transactional relational database, which is roughly speaking CSV sort of in inspiration at least, and they're getting more into this type of thing. So, you know, accessing data from a MongoDB database feels a lot like accessing data from a JSON file. But anyway, so good. So the basic format, the overall file, is either a list or a dictionary. Every entry can be one of the following: lists, which are enclosed in square braces, delimited by square braces; dictionaries, which are enclosed in curly braces. Every key is a quoted string. Unlike Python, where a key can be literally anything, in JSON files, all of the keys are strings. And there's a reason for that. Think about objects, right? The purpose of a dictionary in a JSON file is to emulate the ability of objects to hold fields, right? Or attributes. The attribute names in an object correspond to the keys of the dictionary in the JSON format. So, because attribute names, field names are strings, it makes sense that these are strings, right? In terms of syntax, it's exactly the same as what you're used to in Python. You have quoted key name, colon, and then whatever is in the dictionary, right? Then the value. The value can be any kind of entry, so it's list, dictionary, number, string, boolean, or null. And of course, aside from lists and dictionaries, each entry can also be a number, int, or a float. Strings, which are enclosed in the double quotes here, double quotes. All of you Python programmers who've gotten lazy about single versus double quotes, not everybody recognizes that there's no distinction because there is a distinction. Most of the places that you will go, double quotes means a string, single quotes means a character. So you should get used to using double quotes even if you're inclined to use single quotes because you don't have to hold the shift, and it is like infinitesimally faster. Booleans, true or false, and null things. Does that make sense? Any questions? Yeah.
Float was a typo, yes?
Yes.
Okay, good.
Yeah, that was, yeah, I was having a jink. Yeah. Yeah, that is a typo. We haven't covered flayouts yet.
Okay, yeah.
Yeah. So, hearkening back to our person object from a couple of lectures ago, if we were to compose this data into a JSON file, we would get the following. List at the top level, 3 dictionaries contain, right? Each dictionary contains name, year, spruce, children, right? Children contains a list, which also contains strings, right? It just collects all of it out, right? So how do you navigate a structure like this, right? Let's say we wanted to get the year of Hermione Granger's, I don't know what year means in this context. I'm going to assume it's the year in which the hat she wore at graduation was made or something, who cares? To access this data right here, we have a list at the top level, so we have to get to it by indexing, right? So 0, 1, 2, 1. From there, we access the year field. Again, just using the same square brace notation, right? But you can apply these, like you don't have to separate them, right? If you were to do that in one line, it would be like persons at 1 year, right? Make sense? Good. Delete. White space, that is to say, spaces, tabs, line breaks are irrelevant in JSON files. There is no semantic content to the spacing. So, in theory, you could put all of this on one line and it would work. Like, that is to say, it would be a perfectly parsable JSON file. The computer would still know what to do with it. This might come as a shock to all of you Python people, because when we program in Python, we're very particular that like the indentation is correct because it carries semantic content. We make sure that, you know, well, it's mostly the tabbing, to be honest. But in this, the tabbing only is indicating the nesting of the data structure because either it was generated that way by the program that generated the JSON, or some human being went in and put it in there, but it doesn't have to be like that. And they can get pretty confusing, but generally speaking, like, tabbing over with the degree of nesting is like, that's like the conventional way of approaching it. So, I don't think that we'll have time to get into reading and writing JSONs. So if there are any questions, I will answer them now. Otherwise, I think we will adjourn until Wednesday. Okay? Good.